Welcome back, students. In the last video I was covering the conservation of energy, and I did an example like this where I had an object falling off of a cliff and I gave you the mass and the height. We verified that the potential initial plus kinetic initial was equal to the final potential plus final kinetic. In this process, the ball starts with all potential and no kinetic because it's right before it falls off the cliff. And then after it falls, right before it hits the ground, whenever it's going the fastest, that's whenever the height is 0, so there's no potential and it's all kinetic. So the energy transforms from all potential to all kinetic from the beginning to the end. At the halfway point, it's going to be split between potential and kinetic evenly. It'll be like a 50-50 split. I'm going to reapproach the calculation I did last time, but just using energy and not using the old kinematics free fall equations. So let me show you how to do that. Okay, first I'm going to find the potential energy initial with this problem. I have a mass of 30 kilograms and a height of 13 meters. Potential energy is equal to mgh. I'm going to rewrite this equation in terms of what each of these things are. Okay, so I've rewritten this equation, the conservation of energy equation, in terms of what the potential energy is and what the kinetic energy is before and after the process. Okay, this is going to allow me to figure out what to cancel out and what to calculate more easily. Okay, I know that I can calculate this because I have my height and my mass, and I know g is 9.8. Because I know that it's not moving yet, I know that the initial velocity is 0, so I'm going to cancel this whole term because anything times 0 is 0. Okay, and then I know at the end of the process, all the energy is going to be in the kinetic form, so there's going to be 0 potential because there's 0 height, right? The height final is 0, so everything times 0 is 0. Now I know that the initial potential is going to be equal to the final kinetic. First I'm going to solve for the potential here, and then I'm going to be able to make that equal to this and solve for the final velocity in a more easy way than using the old kinematics equations. Okay, here I plugged in my numbers for my potential energy. The mass is 30, g is 9.8, h is 13. I'm going to plug this in my calculator to find what the potential energy was. I found that the potential energy was 3,822 joules. Okay, if I solve this for my final velocity, I need to multiply both sides by 2. Okay, I need to divide both sides by the mass, and then take the square root of both sides. Okay, so after I clear all this clutter out of the way, it's just going to be this is equal to Vf. Okay, and this gives me the final velocity is equal to the square root of 2 times the potential energy divided by the mass. But before I solve for that, I want to take a moment to clarify that in this kind of problem, the final velocity is going to equal the square root of 2 times the potential energy divided by mass. Okay, so you can just save this equation for another time too. Okay, now I'll go ahead and solve for the final velocity in this situation. After I put this in the calculator, I got 15.96 meters per second. Okay, and I didn't have to use any old kinematics equations. I just used the fact that I know that the potential energy initial is going to equal the kinetic energy final. So I put that in equation form, and then I'm able to solve for the velocity. With this same example, I'm going to find the velocity whenever the ball is halfway between the ground and the top. Okay, if I wanted to find the speed of the ball whenever it's at the halfway point, I'm going to start with acknowledging that the initial energy, we calculated this earlier, this is mgh. The initial potential energy is 3,822. Alright, so I know that at the halfway point, it's going to be half kinetic, half potential, because it's half the height. So if I divide this by 2, I'll know the kinetic energy at that point. Okay, so here I just wrote out that the 3,822 divided by 2 is going to be equal to the kinetic energy, and which is equal to, of course, 1/2 mv squared. I know at the halfway point, the kinetic energy is going to be 1/2 mv squared, which is going to be equal to the initial energy divided by 2. Okay, if I solve for velocity now, I can multiply 2 to both sides. Okay, that lets me cancel out the 2's on both sides. I can divide m to both sides, and then take the square root of both sides. Okay, and if I clear this up, I'm going to have velocity is equal to the square root of 3,822 divided by m. When I clear this up, I get velocity is equal to the square root of 3,822 divided by m, which is 30. If I plug that in the calculator, I get 11.29 meters per second. Okay, I hope this makes it easier to figure out velocity throughout the process. Thank you.